Hi everyone, welcome back to my YouTube channel. In this video we shall finish up with the series, the geography walkthrough or review of the November paper 2023. Okay, so we'll be going through the map work of paper 2. Of course, we've already done the paper 1 map work. So let's start and do this. So this is of course section B, and this is question 3, which is geographical skills and techniques. Okay, now you should have been provided with a Gqeberha map. Okay, so you should have a topographic map and of course an orthophoto map of Gqeberha, and that's about it. Okay, so we know that Gqeberha is in the Eastern Cape. And so let's go through the extract and then the questions. Okay, now we are provided with the coordinates of Gqeberha, of course, and so they say Gqeberha is a major seaport, which is a harbor and a densely populated city. Okay, meaning which it has many people that live close to each other, right? In the Eastern Cape, in South Africa. It lies at Algoa Bay in the Indian Ocean. Okay, the residential area is on a flatland with an industrial sector at the north end. Okay, so it has an industrial sector. Gqeberha is characterized by a large number of green belts. Okay, so remember guys, green belts, these are like the open space areas where we do not allow any building, any kind of building there. Okay, so that is what green belt is. Okay, so the Kruger Industrial Development Zone, the Kruger IDZ, is located close to Gqeberha. Okay, so we of course are done with the question that is concerning the Kruger IDZ. So if you haven't watched that video, I will leave it in the description. Okay, it has a world-class infrastructure which provides for the increased accessibility of services and industries to the rest of the world. Okay, so that is the extract on Gqeberha. Okay, right now let's look at the questions. Start tackling the questions. Of course, this is question 3. We'll start. Let's see what do they have for us. Okay, right. So these are pictures that I took of the map. Okay, so I just hope that you guys do see them. Okay, yes, there we go. So you should have been provided with a topographical map, there it is, and of course an orthophoto map as well. Okay, I know that they are quite bright, but we should be able to use these maps to answer these questions. Okay, right. So start with 3.1, which is map skills and calculations. Okay, so 3.1.1 says the scale of the orthophoto map. Okay, the scale of the orthophoto map. So we have 4 options. This is a multiple choice question. The first option, which is option A, says 1 centimeter represents 100 meters. The second option, B, 1 centimeter represents 100 centimeters. And then C, 1 meter represents 500 meters. And then D, 1 centimeter represents 500 centimeters. Okay, so these options, or this question basically is asking us, what does the scale of the orthophoto map represent? Okay, so what is it saying to us? Okay, now remember on the orthophoto map, this is its scale, okay, which is 1:10,000. Okay, and we usually of course interpret this as 1 centimeter represents 100, I mean 10,000, 10,000 centimeters. Okay, so this is what we interpret it as. Okay, 1 centimeter represents 100. I don't know why I keep saying 100. 10,000 centimeters. Okay. Now, which choices or which options there correspond with this? Okay, so which options corresponds with 1 centimeter represents 10,000 centimeters. Okay, so we'll start with the first one, which is A. Okay, so it says 1 centimeter. Okay, represents. Let me use a thicker. Yes, there we go. So it says 1 centimeter represents 100 meters. Now, because we have to, this has to be the same kind of SI units. That means that we have to convert the meters into centimeters in order to see it clearly. Okay. So remember now that in order to convert 100 meters into centimeters, what we have to do is that we have to multiply this 100 meters by 100. Okay, so we're basically saying converting this. Okay, so we'll say 100 meters, multiply that by 100. Okay, so what do we get? Okay, so 100 multiplied by 100, we get 10,000 centimeters. Okay, so in other words, this is saying to us 1 centimeter actually represents 10, okay, 10,000 centimeters. Okay, and that of course looks familiar or the same with what we have written here. Okay, so this means that the first choice is therefore correct. Okay, so you just had to convert the meters into centimeters and you would have of course gotten it correct. Okay, so we are not even going to explore the other choices that we have here, so we are going with the first option. So for 3.1.1 we are going with A. Okay, that is our answer there. Okay, right, let's head on to the next one, 3.1.2. right, so 3.1.2 says, zoom in again, zoom in. So 3.1.2 says the coordinates of the stadium at F in block B4 on the topographical map is approximately. Okay, so we are supposed to get the correct coordinates of this stadium at F. So let's go look at the stadium and try to get its coordinates. So this is the stadium that they are referring to. Course, so this is the stadium. Just gonna zoom in there and okay, put a mark there. Okay, so we have so we'll start with, of course, the latitudes, and then we'll finish up with the longitudes. Okay, so the latitudes, of course, so let me take out a ruler here. Okay, let's take out a ruler. This might help us a lot. Then close this up. Okay, right, so guys, if you were with me in the previous videos, you should be able to get coordinates. So I'm just going to line up my ruler, of course, across the map until its top edge lines up with that point right over there. Okay, now we will calculate count actually. So this is at this point right here is 33 degrees 55 minutes. Okay, now this is the whole okay, so this goes from 33 degrees all the way up to 34 degrees. Okay, and each block represents, so this single block, you're going from 55 to 56. Okay, so this is 56 minutes. Okay, so this is still 33 degrees but 56 minutes. Okay, so this is the whole 55 until you reach this point. This is 56, and this is the whole 56 until you reach, of course, another horizontal line there, or latitude right over there. Okay, so this means that we are still at the 56th minute. Okay, we haven't reached 57. 57 is of course, if you can see this black line here, we have our 57 minutes. Okay, so that this would be 33 degrees 57 minutes. So we are still in the 56th minute block. Okay, so we haven't reached the 57th, and we stumble across, of course, our ruler. So this means that this is at the 56th. This F or stadium is at the 56th minute. Okay, now let's try to of course break it down until we have reached, of course, this. So of course we know that if this is the 56 and this is 57, so the okay, so I can um, so let's rotate this so that can actually break it down. Okay, zoom out and let's do that. Okay, right, and of course I'm just lining up my ruler, just ensuring that um, it is lined up correctly. Okay, there we go. Right, so if that is at 0 and this is 2, so that means that our half is at 1. Okay, so we have our half right about here actually. Okay, let me use thinner. There we go, right about there. Okay, so let's rotate our ruler again. Okay, and then ensure that it lines up again with extend it, show that it lines up again there. So we know that our half is right over here. Okay, so we know that at this particular point uh, the minutes is 30. Remember, I mean the seconds is 30 seconds. Okay, so 30 seconds is right over here. Okay, and if we further, so if we can further, okay, line this up again, so that is our half. So looking for the half of a half, which is about 15, so that is 1, so 0.5 is a half of a half, so it should be somewhere there, right? So that is our that should be 15, right? Okay, right, then let's line it up again, and then so this means that our point is actually below 30 but it's actually above 15. Okay, so that means that it's saying that it's 33 degrees 56 is at the 56th minute, and it's at around, so if this is 15, should be 18 or 19. Okay, 18 or 19. So I'll say 18. Okay, 18 minutes seconds south. Okay, that is our latitude. Now let's take a look at our longitude. Okay, so our longitude, of course, are our vertical lines. So we have to ensure that our ruler is vertical like that, and so this is how we're going to count. Okay, so this is 25 degrees 33 minutes, and this is 25 degrees 36 not 36, 34, sorry about that, 34 minutes. Okay, so it says 25 degrees 34 minutes, and this whole is 34 minutes until you reach here, that is 35 minutes. Okay, so it's 25 degrees 35 minutes. Okay, this is the whole 35, and so this is the whole 33, this is the whole 34, this is the whole 35. Okay, it's the whole 35 until you reach, there we go, 36. So this is 36 minutes. So it's still 25 degrees 36 minutes. Okay, so now that means that, and if you really take a look at this, you can see that it's actually right on 36. Okay, so that means that this makes it easy for us. So that means our longitude is 25 degrees. We said the 36th minute, so 36 minutes and 0 seconds east. Okay, so this is what we are going with, guys. This is the coordinates. I'm using estimation, by the way. It could be precise, but it can consume time. Okay, so I'm going with 33 degrees 56 minutes 18 seconds south, 25 degrees 36 minutes 0 seconds east. Okay, so um, uh, which option are we going with there? Okay, so we do have A, which is 33 degrees 56 minutes 19 seconds. Okay, 19 seconds. Okay, I'm quite close actually, so it's actually 19. That's quite close, so that's right. So, and then, so this is correct. So for this part it is correct, the latitude part. And then the longitude part says 25 degrees 37 minutes, whereas we have 36 minutes. So it's not 37, guys, it's 36 actually. So this is incorrect. Okay, this is the incorrect part, the longitude. Let's look at the following one. B, 33 degrees 55 minutes. It's already wrong. Okay, we don't have 55 minutes, so this is already incorrect. We have 56 minutes, right? And then let's look at C, 33 degrees 56 minutes 19 seconds. This part is correct. And then let's look at our longitude, 25 degrees 36 minutes. Okay, there we go. We actually got 36 minutes. There we go. There we go. So yes, so these are both correct. So we'll have to go with C. Okay, and I'm looking at D has 57 minutes, so this is incorrect. So guys, we are going with C. Okay, going with C on this one, which is 33 degrees 56 minutes 19 seconds south, and 25 degrees 36 minutes 0 seconds east. So that is our answer there. Okay, so let's write that down. So we're saying that our answer for 3.1.2 is C, right? So let's head on then to 3.1.3, right? Calculate the distance of the runway in meters. Okay, so the distance of the runway in meters between 6 and, so between number 6 and number 7 on the orthophoto map. So between number 6 and number 7. Number 6 and number 7. Now, I've already calculated, so anything that had to do with calculations, I already pre-calculated it, and found out, I don't know what you guys found out, but I actually found out that it's actually 14.1 centimeters. Okay, there might be a few variations here and there, but it should be close to this. Okay, so let me know what your measured distance was, but mine is 14.1 centimeter. And so let's use the formula to calculate the actual distance, because this is the measured distance. Okay, and so we know that distance, I'm not going to rewrite the formula, guys. I don't think you do get marks for that. So going to say that so actual distance, should have written actual, the real distance is equal to the map distance, which we found as 14.1 centimeters, multiply that by the map scale. Okay, remember this is a orthophoto map, so the map scale of course is 10,000, right? So multiply this by 10,000, and then what do? Okay, we divide all of that, by what conversion factor, guys? So when you are moving from centimeters to meters, what do you divide by? Okay, of course you divide by 100, right? So we divide by 100 then. Okay, so of course that counts, so these zeros, so 3 of these, 2 of these actually cancel with that. So now we are left with 14.1 centimeters multiplied by 100 actually. So that is our that's what we have there. Okay, 14.1 multiplied by 100, and on your calculator, what do you get? So yes, that should give you 1410, right? What? And 10 what? 10 meters, right? So that should be about it. Okay. Okay, and then let's look at the following answer. Following question. Following question says, why does the runway between 6 and 7 appear larger? Okay, appear larger on the orthophoto map as compared to the topographical map. Okay, well, that's because, guys, the orthophoto map is larger than the in terms of scale, so it is a larger scale map than the topographical map. Okay, by larger scale, guys, what do we mean? We mean that, and a lot of students really confuse this. They are quite confused with this notion that a larger scale map shows more detail. Okay, larger scale map shows more detail, and because this is a larger scale map, and so that's why you see a lot of things in detail. Okay, and it's not about the number, guys. Actually, the smaller the number there, the smaller the map scale, the larger the scale. So that's because if you look at the number, then that's when you will get it wrong. Okay, so that's what we're saying, guys. Yeah, saying that so we're saying that an orthophoto map, okay, is a larger scale map. Okay, and a larger scale map, okay, or rather, orthophoto map is a larger scale map, or has a larger scale, okay, than, of course, the topographical map. Okay, and it's always gonna be like this, guys. Okay, and okay, map, and of course, a larger scale map shows more detail. Okay, so that is your answer there. You can't get it wrong. Can't get it wrong, guys. Never. Okay, so it shows more detail. Right. Let's move on to the next question then. Just do that. Okay. So our next question is 3.1.5. Okay. 3.1.5 says refer to the topographical map. Use the information below to calculate the magnetic declination for 2023. Okay, so they've already done the first step, which is of course to get the calculate the difference in years. So we are being asked to calculate the magnetic declination, guys. Okay? Already know the difference in years, so I'm just going to write DIY. Okay, not as do it yourself. So the DIY we are given there as 2 years. Okay, so it's 2 years that we have, right? And then what's the next step, guys? Okay, 2 years. The next step is to calculate the total change. Okay, so the total change would have to just multiply the difference in years, which is 2, multiply that by the mean annual change. So let's look at the mean annual change here. So it should be here. There we go. So that's the mean annual change, and it is 12 minutes westwards. Okay, it's 12 minutes westwards, and that's what we are going to multiply that 2 years with. Okay, so we'll multiply with 12 minutes. Okay, so it's very important that you write down these. Okay, so what do you get then? Of course, it's going to be 24 minutes westwards. Then remember, guys, westwards, what do? We add, right? And then eastwards, we subtract. Okay, eastwards we subtract. Okay, so let's look at the current or the mean the magnetic declination that was recorded. In this case, 2021, it's 29 degrees west. Okay, so it's 29 degrees 0 minutes. Okay, so there's can't be a lot of calculation here, so this is quite, it's not very challenging. So we're saying that it's 29 degrees. Do I have degrees here? Probably not. So okay, fine. So it's 29 degrees 0 minutes westwards, and of course we add how we add the total change, which is 24. Okay, so plus 24 minutes westwards. Okay, we are adding, and then final answer is 29 degrees and 24 minutes westwards. Okay, right, this should be it, guys. Okay, it's easy as that. Okay, so let's then move on to the next question. And our next question is 3.1.6. Okay, and 3.1.6 says what is the purpose of calculating the magnetic declination for the current year. Okay. So now guys, magnetic declination, right? So let's take a compass here, just quickly draw a circle. Maybe should be a lot. Okay. So with this circle, guys, so this is your Earth, and your Earth has what we call true north. Okay, maybe let's use a thicker line. Has true north, the geographical north. Okay, so this is your north, and then it has magnetic north. Okay, so magnetic north, so what we are actually measuring, guys. So magnetic north, of course, is the north of the magnetic field around the Earth. Okay, so what we are measuring actually, when we measuring magnetic declination, we are actually measuring this angle right over here. How much is it changing? Okay, how much has it changed? Okay, from true north. Okay, so this is your magnetic north. Okay, so this is what we are actually measuring when we are calculating the magnetic declination. Now this is very important, guys, when it comes to navigation. Okay, so it's quite important that we calculate this, as it affects the compass direction. Okay, so remember, we are geographers, guys. Navigation is part of geography. Okay, we created maps. This is navigation. So we have to actually correct, look at how much has it changed, how much has this magnetic north shifted from the north, the true north. Okay, so that we can correct our compasses, so that we actually go to the right direction wherever we are going, because it can, of course, if it has changed, then you have to adjust your compass such that, so that you go to the right direction. If it is not changed, if you do not adjust this change, then you are going to go to the wrong direction, thinking that you are going to the right direction. So it affects navigation. Okay, affects navigation. That's why it's important that we write this down. Okay, it's very important that you understand, you try to understand what you're calculating, because this might have been a tricky question for some students. So this is what we're going to say. So we're going to say that the change in magnetic north, okay, magnetic north, um, um, which is, of course, the MD, magnetic declination. So I'm just going to write MD as they did, affects or changes, let's rather say affects, not changes, navigation. Okay, and hence, okay, hence we need to calculate it, okay, to correct navigation, okay, or adjust our compasses for the best or the correct navigation. Okay, so of course, by changing it, by calculating and knowing how much it has changed, then you are definitely going to go to the right location, or to the location that of course you were planning to go to. So so that is 3.1.6, guys. That should be it. So let's move on then to 3.1.7, if we do have that. 1.7, no, we don't. So 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 this is the map interpretation part. This is 3.2 map interpretation, guys. So we are applying what we've been learning. We're applying the economic and settlement geography on MAPWORK. Right. So they say refer to the photographs Y and Z below of residential areas in Gqeberha, Port Elizabeth. So what do we have here? So these are two photographs, and so we can definitely see, guys, that on the left hand side, which is Y, this is your this should be your low income residential area, right? These are RDPs, guys. They all look the same. So this is the low income residential area. And of course, the one on the right hand side is your high income residential area. These look the same, and of course each house, let me actually use a different color here. Each house looks exactly the same. Can I use black? There we go. I don't know if it makes a difference. I don't know. I hope it does though. So that's what we can see. We can see that each house is small, first of all, and it looks like the next house. So these are RDP. So this is low. And then this is high income. Income residential area, right? Let me know, guys, what did you write down? What did you interpret these as? Were you able to see that this is low income and this is high income residential area? Let me know. Maybe let me put them right here, at the top, right at the top. There we go. And let's try to zoom out. Zoom out. Boom, there we go. So that's low income residential area, and that is high income residential area, right? So what we see, guys, here, of course, as I said, the high income residential area, you can see that each house is quite big, and it's really not the same as that is the one that is next to each other, the one that it is next to. So now then they say for 3.2.1a, which photograph, Y or Z, matches the residential area G on the topographical map? So which photograph, or which residential area matches the residential area G on the topographical map? So let's look at our topographical map, and we are looking for G here. So let's take a look at G. Where is G, guys? Oh, there we go. There it is. So this is G. Aha. Okay, so what do you guys think? Which area is this? Is this a low income area or a high income area? Okay, and what makes you say that? Okay, so first of all, guys, I don't know if you noticed this, but you can clearly see that this area is right next to an airport. So this is an airport, this is a runway. Okay, there we go. Chief David Stearman International Airport. Okay, so and second of all, um, this is actually very dense, guys. This is quite dense. Okay, looks dense. Looks like, because as you can see, there's a lot of streets. Okay, it's a lot of streets, and let's compare this area to this area. Okay, this area right here has grid iron. Okay, it has much bigger blocks. Okay, it has much bigger blocks, and this area right over here has quite an irregular street pattern. Okay, where do we see get irregular street patterns, guys? Okay, we get irregular street patterns, of course, in low income residential areas, and because this is next to the airport, um, you can clearly see that, okay, this should be a low income residential area. Okay, no high income would be, of course, be close to an airport like that. Okay, and looking at this as well, I don't know if you can clearly see, look at this built up area. Okay, now for the built up area, we have high density and low density, right? The high density, meaning which houses are very close to each other, there's many of them close to each other, right, like that. Okay, right, like that. Okay, and of course you'll only see that in low income residential areas. Okay, so it should have a darker shade than low density. Okay, the low density has a lighter shade of gray. So take a look at this, and you have this area right over here, which is your G, has a quite darker color, guys. I don't know if you do notice here, has a darker color than that area. Okay, so this would mean that this area is a high density and they are small buildings, as the street pattern also suggests. Okay, and um, the size of the built up blocks. Okay, as you can see, they are quite small. Okay, compared to that. Okay, so that is our evidence there. That's what we're going to write down. So we're going to say that for A, okay, so that is 3.2.1A, right? So let's write that down. Our answer there is saying that it matches Y, right? And then for B, for reasoning, we're going to say, so according to the map, it is a high density. It is a high density area. Okay, so we'll just put the darker shade of gray. Okay, of gray, right, from the map. Also, you can say irregular pattern, street pattern. You can say close to the airport pattern. Smaller buildings. Okay, so there's quite a lot of clues there. I'm sure there are ones that I did not even explore. Okay, right. Okay, so that is our answer there. Okay, and then we move on to the next question, which is 3.2.2, guys. Okay, so for 3.2.2, so before that they say Gqeberha has a number of green belts. Okay, all right, and then 3.2.2a says give an example of one type of green belt on the topographical map. Okay, let's explore this. So we should have a number of green belts here. So of course green belts, you do not see any buildings. Okay, for an example, the Walmer Golf Course, that's a green belt. The Settlers Park Nature Reserve, that's a green belt. What else, guys? The golf course, it's just a golf course like that, that's a green belt as well. North Air, no, that. Okay, so I'll go with the Settlers Nature Park. You can go with the golf course, you can go with the Walmer Golf Course, but I'll go with Settlers Park Nature Reserve. Settlers Park Nature Reserve. Okay, so that's what we're going with there. Settlers Park Nature Reserve. Okay, so that is our answer for 3.2.2a. Right, let's move on to the next question there, which is B, 3.2.2b. And it says, how do green belts reduce environmental injustices in Gqeberha? Okay, so that's 1 point, so that's fine. Well, there's many ways, guys. I mean, green belts, first of all, they preserve biodiversity. You can say that they absorb the unwanted carbon dioxide, okay, and release oxygen, which is what we need as clean air. They prevent floods, so or floods. Remember, we've built up a lot of areas, and so we are very prone to flooding. But these, of course, are very protective of us. Okay, so that is how you answer that. Let's move on. Okay, Gqeberha is characterized by light and heavy industry. So these, we all saw these, of course, in the general information part. Okay, so they're now coming back. Okay, so this is 3.2.3. 3.2.3, let's write that down, guys. Let's write that down. 3.2.3. Okay, and it also has A, B, and C. Right. So A says, give evidence from the topographical map that north end, which is H in blocks, A4 and B4 is a heavy industrial area. Okay, not a light, but a heavy industrial area. Let's take a look at this. B4 and A4. B4, A4. So actually referring to this area right over here. Okay, so that is our H there. Okay, so what evidence suggests that this is a heavy industrial area? Okay, of course, that's first thing I would do. I would look at its location. Okay, so as you can see, it's far away from the residential areas. Okay, so it's on the outskirts. We can clearly see that it is next to a major road, or major national road right over there. Okay, because of course of the pollution, noise and air pollution. Okay, so yeah, guys. Okay, it's close to transportation sites or routes. So that is what I see. Okay, you might have or might have seen a different evidence. So that's what I'm going to write. um, saying that it is okay. So we see concentration of buildings, uh, buildings which are on the outskirts. Um, of Port Elizabeth, so I'll just write PE. And they are next to the national road. Okay, I made a mistake. The national road, of course, uh, for transportation of goods, of finished goods, uh, of finished goods. Okay, that's what I'm going with. Right, let's move on to B. Okay, so guys, we are moving, we are moving, we are moving. So B says identify the human-made feature that would limit, okay, the North End industrial area H from expanding towards the. What is a human-made feature? It has to be a human-made feature that is limiting the expansion of this industrial area to the north. Okay, so it should be the cemetery, guys. Yeah, the cemetery there. Yeah, it should be the cemetery, okay, because that is human made. Okay, so we'll go with that. Okay, the cemetery. Okay, so and it's called the North End Cemetery. Okay, move on to the next question. How would employment opportunities created by industrial area H be of economic benefit to the local area? Economic benefit. Okay, so this is economic geography. So I'm going with skills development, uh, results in individuals, um, implementing skills, uh, these skills in their independent businesses. So, of course, when you do, I'm sure you do have some people in your community um, who actually worked maybe in the construction sector, and they are now actually building or helping build houses for people. Okay, so oh guys, I made a mistake here. Wow. Okay, so this all of this should have been yeah, made a mistake there. Okay, oh actually no, I didn't. Okay, no, I didn't. Okay, yeah, that's fine. In their so that way they make money. Okay, generating income. You can write increased buying power. Okay, so that's how they benefit. There's many more even. Refer to the topographical map and the orthophoto map Why is the airport located in the rural urban fringe? Guys, I don't even have to look at. So that is 3.2.4. I don't even have to look at the maps, guys. This is so to prevent or protect people from um, residents, of course, in residential areas from noise and air pollution. Okay, right. Okay, let's move on to the next question then. So that's 3.2.4, and we have one last question, 3.3, which is GIS. So that's 3.3.1. Okay. Refer to block D2 on the topographical map. Okay. Give evidence that buffering is taking place in block D2. Buffering is taking place. Remember buffering, guys. What is buffering? Buffering is to mark off or to demarcate around the area. Okay, so that is what buffering is. And let's take a look at this D2. D2, D2, yes, there we go. So D2, right. So guys, we can clearly see that there is buffering right here. Okay, so that's buffering, guys. Okay, and can see that, I don't know if you see that, you can see that there's actually um, a river there. Okay, so you have a river that is running down there, so that is to protect people from the flooding. Okay, so we can clearly see that, and can see that there's hiking trails here. Those are hiking trails, right? The dotted lines. Track and hike, yeah, track and hiking trail. Okay, there's a track and hiking trail. So we can write that down. There's a track and hiking trail around so that's what we're going with. So let's do this rather, track and hiking trail around the river. Okay, you can say houses are at a distance, okay, from the river. Okay, so that's what we can see. Okay, so that is the evidence of buffering there. Okay, let's take a look at 3.3.2. So it says, what is the purpose of buffering in this block? Okay, so well, guys, there's a river here, so we're trying to prevent flooding. Okay, it's simple as that. This is to prevent, not to prevent flooding, but rather to prevent excessive damage. Damage of the residential area of the neighboring, okay, residential area, um, okay, of the neighboring residential areas, um, when this river floods, when the river in this block floods. Okay, okay, right, okay, okay. Before refer to block B1 on the topographical map. Okay, let's look at B1. Where's B1, guys? B1, 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 B1. There we go. So this is a B1. Okay, what about B1? Okay, so first question, which is 3.3.3, says what is a data layer? What is a data layer? Okay, so a data layer, guys, is essentially it's a layer representing, or geographical layer representing a specific type, okay, of information, okay, um, about a particular area, right? Yes, so that is our answer there for 3.3.3. Then 3.3.4 says identify the transport data layer in block B1. Identify the transport data layer in block B1. Okay, so what is transport data layer? So it should have information about transport then. So it should be, so what do we see as the transport, or as transport here in B1? Okay, well, I actually do see quite a lot. Wait, so wait. Oh, okay. Um, so transport data layer here. So we actually have different types of roads here. We have this road. Okay, what road is that? Let's look at our. Let's take a look at. It's actually white in color, so it should be other road with a thicker color. Thicker. So it should we see. No, not other road or railway. Other road. We actually do see a national freeway there, because I did see a blue line there. There we go. What else do we see? There's this gray line here. Should be a different road, and I don't know if this is red or green. Okay, so that should be national road. secondary road, and I think arterial route. So I think it should be these four guys. Okay, not quite sure about that, but should be these four because that's the information about transport that we have there. So other road. How many marks? It's just one mark. National freeway. Arterial road. Uh, and what's the other one? Did we say? Oh man, secondary road, right? Yeah, secondary road. Okay, so that's the information about and secondary road. Okay, that's what I would have written, guys. Let me know what did you guys write in the comments. Refer to I in block B1. 3.3.5, last question. Yes, ma'am. Why would the transport data layer, okay, so this cause traffic congestion? Why would this cause traffic congestion, guys? Why would these roads cause traffic congestion? Um, well, let's take a look at this again. So, traffic congestion, well, okay. So, what type of street pattern do you see, guys? What type of street pattern is this? Okay. So, yes, this is a grid iron street pattern or rectangular street pattern. And as you can see, there are many intersections, and so of course, why not? Of course, um, there's a lot of stop and go. Sure, of course, in each and every one of these, there's probably a traffic light. So yes, okay, all right. What did you guys go with, guys? What did you go with on that question, the last question? So say that um, so due to the street pattern design, which is the gridiron, um, there is a lot uh, of intersections, and hence traffic congestion. Congestion. There we go. So that's it, guys. So that's our review for the Geography 2023 MAPWORK. Okay.